This meeting is being recorded.
Oh, that was loud. Okay, so I'm Martin Hořeňovský, and we will have a short talk about undefined behavior in C++. I titled it "So You Want to Remove All UB," because I see a lot of people kind of arguing in this direction, and I think this is not a good direction to take. But like, I can't take anymore. You have something on the. No.
Yeah.
Okay, so we all hate undefined behavior, right? We have talked about this like in the last 10 or so minutes, and like we hate it for a good reason. Like we have this nice, reasonable code that should just write puts a couple of times, and we give to the compiler, and we get this. And you know, notice that the jump is not conditional. This will do forever, because there is UB. This would require integer to overflow. This can't happen. That's undefined behavior. So it's optimized out, and we just keep printing over and over again. And similar example, right? This is infinite loop, because see that we have like a function that just returns the input plus 1. And we say, so is number plus 1 equal to the original number? No, it's not. It will never be. So, and you know, so we should do forever, right? No, the compiler says no code for you. There is literally not a single instruction in this code after you compile it. And finally, like I won't give you the assembly for this one because it's hundreds of lines due to the input and output handling. But notice that we have some like array of elements, and we want to check if some input there is inside this array. And I made a tiny mistake. I wrote I is less or equal 4 instead of just saying less than 4. That's how many elements are there, right? So we compile it, not even with like O3, just O2. And we start asking questions, which numbers are there? The answer is all of them. As long as it fits into an int, the number is there. Why? Because if it wasn't there, there would be undefined behavior. We can't have undefined behavior. So this function is just constant, and until we break parsing for integers, the answer is true. So what is undefined behavior? Well, it's a contract. It's a contract between the programmer and the compiler. You know, the two people who are involved in writing and code and then translating it. And the programmer, us, we say something will never happen. Like we will guarantee as a programmers that the error, the undefined behavior, will not happen. And the compiler says, fine, you will handle this, and I will optimize the code as hard as I can, assuming you aren't lying. Well, why is this? So the issue is that a lot of interesting properties of code can be proven locally. And you know, C++ compilers compile each function on its own. They can look into other functions, but the default is to assume that they can't see any other function. And you can't prove a lot of things anyway. So the undefined behavior says the programmer has to handle this. Is the issue? It's the issue of the human. And can we get rid of undefined behavior? So, no. Wait, no, it's not like strong enough. No. And I'm going to say that if you actually want to get rid of undefined behavior in C++, then one of two things is true. One, you don't understand what it does in the language, why it exists, or you should not be using C++ at all. You should be using safer language. Let's look at some of the examples that undefined behavior gives us. Okay, we have some function f, you know, we have some input, and we have some other helper function that just debug prints and pointer. You know, and it says, oh, if it's like null pointer, and if it's not null pointer, it references and prints it actually like give us the value. You know, this is the sort of thing that you can find yourself later when you are just doing debugging and trying to figure out why is everything broken. And you know, and when the compiler sees this function that like takes the address of a reference, passes it to the debug print, it should give you something like this. But why can it give you this? Why can it inline the function and then say, well, this is never null, so I can just go back to like dereferencing the pointer. This should be just referring to the reference instead. Why can you do this? Because if it was null, it would be undefined behavior. references are not null on the plane of undefined behavior, but the programmer is responsible for handling this because the compiler can't prove this. It can prove it in tiny cases, but not in the code, not in the totality of the code that it is to handle. Another example. This is simple prefix scan, prefix sum of an array. We give it some length, we give it some floats in an array that it has to prefix sum. This basically means for every element in the array, it will write in the sum of all previous elements. This is useful often for some algorithmic code. And when we compile it, well, sorry, the PDF conversion took out a lot of this, but trust me on this. This is where we load the length from the pointer. Right? We load the length from the pointer, and then we loop here. And notice that we don't load the pointer again. We don't have to load the length again. Why? Because if this write to the array overrode the length that we got, that would be undefined behavior. This is aliasing. Aliasing between different types can't happen. If it happens, it's the programmer's fault. So, can we get rid of undefined behavior? Well, what about integer overflow? Yes. I mean, we have voted in the fact that integers are also 2's complement. Right? Just as unsigned integers are 2's complement since C++ 20. But 20 or 23, signed integers are also 2's complement. So we can say, overflow is the nature of behavior and just do it, whatever. So we could do that. Would we handle infinite loops like this? Can we say, actually, infinite loops are fine. We should accept them. Good question. It depends. What's your opinion on these two snippets? Should compiler be able to take this code and compile it as this code? If your answer is yes, then no, you need to make infinite loop UB because this requires forward progress guarantee, which is what actually makes infinite loops undefined behavior. Okay? But if you are fine with saying, no, you can't optimize like this, you can't give me this, you have to give, I will always just compile it like this. You can say, forward progress is not that important. Let's, undefined behavior infinite loops. What about others? Like new references, aliasing. Everyone has different opinion on this. Because to some, they just cast pointers between different types. They compile their code with I don't know what the flag is, but the one that disables type-based aliasing. And they are like, yeah, this is fine. I don't miss the performance. But to other people, this would be terrible. So, I don't know. But we can't just say we will remove all undefined behavior because half of the optimizations C++ can do that are not just p-hole optimizations where you take 5 instructions and just make them slightly better, rely on the fact that for non-local reasoning, compiler can be like, yeah, that would be UB, so that's not happening. And that's all.
Yeah. You can keep the.
Yeah.
Undefined.
Can you just use the mic? I turn it
It's
on.
for me.
Yeah, it's for online.
My question is if you have used undefined behavior sanitizer and if it does reliably catch all anomalies at runtime or it still misses things?
That's a good question. I don't actually know whether it's sound, whether it guarantees that it catch everything. I know that since it integrated with the compiler, it can make sure that the checks that it inserts will remain there. I can't. Well, yeah. Obviously, there are classes of undefined behavior that it can't catch. So I would say that I would depend on the UB side that for the classes of undefined behavior, it promises to catch. It will catch them. This is things like bad v pointers, integer overflows, null days, and similar things. But it can't promise to catch every case of undefined behavior, just because like some of them are in the library and some of them are not like provable in general.
Okay, thank you.
I actually have a question. I hope this is working. It's not blinking.
Microphone.
It's probably that. Doesn't matter. Yeah, so my question is actually, is there somewhere a list, hoping on CPP referral for all undefined behaviors?
There is list of undefined behaviors for C standard. It's appendix something. Like it's one of the appendices. Look it up. There is no such thing for C++.
Amazing. And what about library undefined behaviors? Like they say, I don't know, there was, I think in optional or expected, like if you use dereference operator or like star to dereference invalid expected, it's undefined behavior, but like you need to put some code there. So how does that work?
This is usually used to basically say it will do the naive thing, and whatever happens, happens. Like like when you have vector and you have like the index operator, and you just put there like 1 million, which is outside of the vector, then what it will do is usually that it will just try to dereference the element of 1 million, but the compiler is allowed to just look at it and go no. Because like this would be undefined behavior to do, and propagate this upward and end up with whatever.
Okay, thank you.
So maybe like the compiler isn't out to get you, right? It's not like thinking, okay, and now I'm going to get him. It just goes, okay, so what's the least work I can do, and then it goes and takes information, right? Okay, so I know this can't be null because this pointer was created from a reference. And then goes, well, if I know this can't be null, then checking it for null is pointless. Let's delete the branch and let's eliminate any code in there. And that's what happens. It's like it uses undefined behavior to gather information about your code and then optimizes the code according to the information it has. It's just that UB means that the information can be wrong because you told it a lie.
Okay, so, sorry, I guess turning off and on this thing a couple of times just is not a good idea. So there is a question from online, like libsted C++ has a few macros to enable asserts in containers and iterators.
Yeah, that basically means that when you use index operator, you will assert that it's in range. So you have one predictable behavior, and it will anyway tell you that this is broken, and every standard library has this mode. MSVC STL has it by default in debug mode. It does a lot of checks. libc++ also has a lot of defensive helpers to help you. Like for example, it will shuffle inputs to unstable sorts, so you don't rely on the exact order that you get. But obviously, this is opt-in behind the macro because it has runtime cost, and no runtime cost over what is necessary.
Yeah, there was the talk about stud. Yeah, like sort can go out of bounds if the less than operator is not
consistent.
Yeah,
that's just the grammar error. You are supposed to give it predicate that is consistent. If it's not, then whatever.
I was just
Who's supposed to handle this?
I really like this sentence. You're supposed to handle this. It's real. Okay, so I guess we can move to the next. You can keep the microphone and we'll use the other. And also how do you use is this for the, amazing. So let me just close this one. Oh, look at that. perfect. Right. Take the microphone and take the clicker. Yeah, I should be okay. Yeah, it's not smart to put it like right below your chin because then it doesn't. But yeah, I think people online will complain if
So
there
I
isn't
can
sound.
sound back and forth.
Yeah.
All right. So my topic doesn't have anything to do with the popular topic of we don't like problems caused by undefined behavior. It's more of an observation from my usage of fresh C++ 20 features. So to start, well, we used to use spinner a lot in C++ because it usually ended up, well, allowing us to do something that looks really nice on the surface at the cost of doing something really nasty somewhere deep inside. And well, this was a known issue, and eventually C++20 has added concepts which pretty much solve this, well, pretty much helps you avoid these sphinai almost everywhere, with a few places where it doesn't really work like that, but yeah, it works almost everywhere where you could use sphinai before. So, at first I would like to tell a quick introduction what are concepts in case somebody isn't absolutely sure. So, like if a template function, except that the type that we want to instantiate it on has the right properties, we can use a concept to enforce it and prevent it being used with other types. Usually, while using it with the wrong type, resulted in compiler errors. But in some cases, I guess it could even cause incorrect behavior. But like that hypothetically can exist, but I don't think this ever happened to me. So, but with concepts, if we want our code to work with string, but we also want this to be a library, and we would like it to work also with some custom strings. So we can basically create a concept that requires the methods that we need. Oh, well, why do I have this indentation? So, yeah, the point is that we want it to be constructible from string view, and assignable. So we just write some kind of expressions that can do this. And yeah, we want to be able to append it using the plus equals operator, and we want it to be convertible to string view. And yeah, this is what we want. And like, if these are all the functions that we need, basically we use this concept of string, use it instead of type name when using template, and it will just not even start to instantiating and just tell us what is wrong immediately and try to instantiate it. And we get a nice error message also. So, well, because if you just do type name t and then get somewhere inside and it's missing some function that you would like to call on it, you get its error inside the template and like, looks like the template was wrong. Like, no, it's not the template, it's just you are using it wrong. But like, this is hard to debug, so also this is super useful for this. So, like, when C++20 became readily available, I started using it pretty much everywhere where I could, because it was awesome. I could just do code completion. I just wrote a concept and the IDE was automatically filling what was there. Yeah, I was always missing this with templates. And of course, concepts allow inheritance. Oh, not really inheritance, but you can like require it to like use some other concept that already exists to extend them. You can do stuff that would be, in case of sphinai, so crazy that you would just not even try, such as returning concept from a concept that checks if some method call returns another concept. So like these are pretty fancy stuff that we can do now. Of course, if we do something wrong, it will just print it out nicely at the place where it happened. Another thing that was awesome, we can use it for overloads. Doing this with Spina was possible, but it was always like ended up with some really nasty large number of overloads of class specializations and other stuff that was always pretty nasty. And also, if we had some dependency injection, we could just use template arguments instead. Because, well, we can just create the object ourselves, and if we are testing the code, we just throw there another object. This was like super useful. And so I started using this, and turned out, well, it had its own set of problems, and especially when it came to like using it on a more wider scale. First problem was that, well, okay, so I use a concept here, I use a concept here, and like I used it more widely, and then I ended up like 5 template arguments. Some of them were just classes that had more template arguments than their own. And like I had to copy paste it because there was no way to remember anything like that, anything like what would I fill there. And additionally, there was no way to get some reasonable code completion there. So this was getting really out of hand. And also, I could get clean functions that had just 1, 2 arguments. But when I was trying to use anything there, I had to fill all those template arguments that like completely defeated the purpose of clean code. Of course, in case it was more complicated, there was a constraint that was not satisfied because the return type of some code does not satisfy something else, because there was a lot of overloads, but neither of them did match, and the one that I wanted to match actually didn't follow some yet another constraint. And yeah, this was only on the later compilers. The earlier compilers just crashed. And well, there is also the problem that sometimes you want the concept to actually have some kind of recursive behavior, that you want it to accept the same concept as argument or return it. And this was now getting more out of hand. I'm not even sure how the recursion was supposed to work there. And yet another issue is that, okay, I have a concept here, and I know that I am using this with some class. Where is the class? How do I navigate through this code? Because, yeah, there is a class that was supposed to have these methods, but the method names are quite generic. And like, which of all those classes that I have there is actually the one I was supposed to use, or expecting it to be used there, so that I could look into it when I'm just trying to read the code, just implement some other class there, so that I could just look how it is like at the class that's working. Like, the code navigation was absolutely insane there. So in the end, I realized that, well, I should hold back with this. Like, yeah, it's nice, meta programming on the highest level, but like this kind of hurts, and I kind of have to stick to some more traditional ways. Yeah, in many ways, we have plenty of more traditional ways that just don't have these problems. Like if I use string view instead of a string, well, it's not writable, of course, but in many cases it is enough. And there is also stat.span, there's the same purpose over other types of containers than just string. And basically it could abstract over any kind of contiguous container. So basically I could just use some kind of specific buffers that I needed that were more complicated, but like I could use this kind of buffer. Pretty much everything is internally contiguous, because if it's not contiguous, it's usually much more complex and slow because you use some gaps and so on. So like this works for almost everything unless you need to actually mutate insert some elements inside. Another thing that worked that like could help getting rid of this a lot was the function. And there was a thing called function ref, which is not part of the standard. It's a library on GitHub by some Tartan Lama guy. And and it's basically like state function, but it doesn't hold it, which means like if you have a relatively large closure, you don't have to care, you don't dynamically allocate, you don't copy anything. And another good thing that worked often instead of that was interface. Like it worked before and like it's still pretty relevant. So yeah, they combine together pretty well, but like one has to use basically all of them. So like I've created an example of something that can be used to abstract over a data format like JSON, XML, YAML, or other things. I didn't figure out how to make that one line shorter, so like it's rather long. So sorry, maybe somebody needs binoculars. I don't have any. So the idea is that we'd like basically just to do the ordinary stuff. We have a format and we are trying to write out something that might be a string, might be an integer, might be a number. And in case of string, we'd like to be able to write really long strings, and we would like to have some kind of streaming behavior that we don't generate a large string and then we just allocate a huge chunk of data because of that, and then just write it and like write it once, read it once, discard. So we might want to have just a fixed size buffer and just write it out. So the idea is that, well, if we want, this is like a general case that we have that there could be some constraints in some cases to optimize it out, but it's not important. We can, for example, if we want to write a string, we just, a string that's like composed of a number of chunks. We just, of course, it might have some key because like in case it's JSON or some stuff. And then the second argument is basically a function that that receives some kind of another functor. And the idea is that, well, we call this function, it does some internal preparation and gives us a functor. And we can use this functor to write out whatever we want. Then this function ends, we clean up whatever we want, and it can just end. So here is an example here, just a simpler way of doing it with string view, so that I could just provide some example that we get the functor here, and we just use it to write it out. For example, numbers would be trivial, and if there was a sub-object, we can get basically use a callback to that would receive some other kind of interface of the same type that could be used to write the sub-object, and then if this functor that we use ends, then okay, we end the sub-object. And I was able to write a JSON library that could write pretty absolutely any kind of JSON with this, and it did no dynamic allocation at all. So, and it was an interface. It wasn't any static stuff and so on. And the interface was just could be as passed as a reference to the function. To the function. So like we wanted to write something into this, we just got an interface, wrote it, and like yeah, we didn't need anything like factories that, or abstract factory that usually always has to allocate lots of stuff and so on, which is the typical criticism of interfaces and similar approaches. So yeah, I was using stud function, but this function rep would be better here because we are not trying. We are always just using stuff that we have constructed earlier on stack, so lifetime is easy. Stuff like this was almost always devirtualized by the compiler, so we didn't have any performance impact. But actually, GCC 13, I found that even stud function with a large closure that would do dynamic allocation is actually inline, and the dynamic allocation is just avoided. So like, I was able to do pretty complex stuff that would normally be done with template arguments, completely without it. And there was so much less template arguments, or even no template arguments. Compilation time, I don't know. It was, but definitely the whole thing was much easier to write. If I got an error, it was just something immediately like you put the wrong type here, and there was nothing overcomplicated. So overall, it's actually important to not to forget that concepts shouldn't be used for everything. Concepts have plenty of advantages, like it can do actually more stuff than interfaces because you have more freedom. You're actually compiling it that way. You are not trying to do something that would be fungible at runtime. Creating an instance of the object is trivial because, well, you cannot have a virtual constructor. You just always end up with something as stupid as, no, not stupid, but impractical as abstract factory. And you got shorter declarations because it has to be shorter actually. And however, if we don't need this functionality, interfaces become very useful because you can get actually much better code navigation because if you inherit from this interface, you just click on the interface in the ID and it tells you, yes, list classes that inherit from this and you are there. Intuitive error messages, okay, there's just one interface, so there is clearly one place when the error was made, where the type mismatch appears. And of course, type names are completely without template boilerplate. So actually, sticking with concepts, it's easy to start, and it becomes quite a nightmare over time when the complexity grows and you try to be too general. So, yeah, basically by overusing concepts, I have discovered a new form of tech debt. When pretty much a situation where, pretty much you get some compile time Python. Because just you get that typing everywhere, you have no idea what is based on what. And yeah, that's all. So discussion now.
All right. Yeah, I'm only wondering about the case of recursive concepts. Why?
You have a tree structure, and you basically at one point you want, and from one node you want to create, or you want to return another node of the same type. But if you use a concept, you might hypothetically even return a different type from there. You still need the concept.
Yeah.
It's the same problem if you have a recursive struct, then when you replace inside of the struct, you cannot place the struct itself inside the struct because then it would be infinite length. So you have to put a reference or some kind of time.
But you can use a pointer, but in a concept, you can return a pointer to you just can have a method, but even if struct, you can return a copy of like this struct of the same type. You can just return it from a function. That's fine. You just cannot have it as a member. But well, actually, it doesn't. It won't even compile for another reason that when you are declaring members, the type that you are just declaring at that point isn't is only forward declared. So it's not valid code anyway. But my point is, with concepts, you basically can do. Well, you have much more freedom. You can like assume that you return some type that still meets the same concept, but like, is it the same? It may, well, you may enforce that it's the same type. That's easy. But like, okay, but how will we just use the same concept as argument to some function, as a return value to some function? And there are many options. But you can do it, but like, how exactly are you trying to get it right? Like you can return a different class that follows the same concept, and like, yeah, this is valid. I would be using it. I don't know, but like I'm pretty confused with the idea. Like, yeah, I can imagine why would I want it, but like, how should this even behave?
Is it even worth it for the compile time costs? That's another good question.
Well, I don't know the exact compile time costs of all of this. It should be faster than Spinay, but the problem is that like once you get the concept, it's really tempting to start using it also instead of interfaces. And like when I was reading some quick guidebook to the Swift language, I have seen that concepts were actually explained before interfaces. Well, concepts in Swift are called protocols, but like it was explained before. Like this is more complicated actually. It just looks in simple usage, it's simple, but get anywhere beyond that, it just doesn't scale.
Yeah. I have a note on the compile times of concepts. Yeah, really fast to compile because in Prague we added another like piece of UB to C++, which is that basically you can cache concept evaluation, and if like there is some weird inclusion order that would change like the result of evaluating a concept, that's UB. So we can actually cache the evaluation much better.
Okay,
But how would you even do it? I mean, how would you invalidate the evaluation of concept somewhere later? If it, like, I would assume that you would cache the validation of concept for a certain type.
I mean, imagine that you say, okay, so is this type streamable?
Yeah.
Okay, so you include the type, concept check, is it streamable? No. You include header that adds the operator.
Okay.
No. Go ahead.
Is this undefined behavior or more like unspecified behavior? Because like it seems like seems like the only thing that can go wrong is that it doesn't compile.
No, it can be different overloads.
Yes.
And since the overloads like will be from templates, you can like end up in a position where you have the same name for different piece of code, which is OBRE, and that's Go state
Yeah, but that's not that's still not UB. That's more like unspecified because
no OBR violations are UB.
Yeah. That's UB, but I have always only seen linker errors from that.
Should we move on? Because these discussions are usually boring for online people, so we can discuss later.
Okay, so how do I take this?
The same way you put it on.
Okay, so I'm returning these tools to you.
Yes.
It's not blinking again.
I mean, you can always try to try. off and on again a couple of times. Or you can, is this one blinking? Yes, please. Or we can switch.
Okay. I'm going to quickly switch.
Ah. Yeah, it's probably best if like this gets turned on once and not turned off anymore. Yeah. And you know what, like turning it off and on again a couple of times always works. So
That works for everything.
yeah, if it doesn't, then you just need to buy a new one. Doesn't work out.
It's the IT crowd method. Okay, does it work? Yes, great. Okay, so this will be like short-ish talk about VC package. Quick question: who here knows what VC package is? 2, 3, 4. Good. Who here knows Conan instead? One.
No,
Oh, well, in addition, like for people who didn't raise their hands. Okay, so a lot of people know about VC package. Like more than half the room, that's enough. Okay, so I will be here to try to convince you that this is true, and I will do
This
it.
wasn't sarcastic.
Well, let's get there first. This is surprisingly not sarcastic.
Yeah,
Even though, I see Martin is already laughing because he knows, my struggles with VC package.
I'm asking because I actually agree that it's a great tool.
Yeah, no, seriously, it's a great. Martin is laughing. No, it's a great. But we are talking on the scale of C++ package managers, okay?
Yeah.
There's some heavy curve going on. But in the context of C++ package managers, VC package is great. But, and this is really important, it's a Microsoft product. And the one thing Microsoft is super well known for, backwards compatibility. You don't get to fix past mistakes. You have to live with them forever. And you will inflict them on your new users over and over again. Because at some point, 7 years ago, someone could use this feature that you have done badly, and now you can't change it. So, let's talk about the fun issues. And fun, Dwarf Fortress is fun. Let's start with version resolution and how it can get inconsistent. This was actually of the issues that I will be showing you. This is the one that I found last, but it's first because it's the most rare and also the most serious. So this is how you define your dependencies for a project in VC package. This is cut off, but it doesn't matter. It's just like the JSON schema. We have some name, boost mismatch, so we will call boost. This is the hash that we are referring to in the package registry. This is how we will know that this is our ground truth for packages. And we depend on exactly one package, boost, circular buffer in version 180 or higher. Simple enough. This is part of what makes VC package pretty nice. It's really easy to use. And so we have this project. Let's install it. So CMake build doesn't matter. Okay, VC package install starts. And we have these packages and a lot more. Boost interdepends on each other. Well, this is not good. Notice the versions of the boost packages that we get. Okay, so circular buffer, which we asked for, 180. Boost concept check, boost passer, boost config, boost core, 179. This is kind of a bad situation to be in because boost gives you 0 guarantees on ABI stability. So if you start linking together parts of boost in different versions, anything can happen. Okay, nothing good. You won't win the lottery. Only bad things can happen, but any bad thing can happen to your code. So that's kind of an issue. So yeah, I found this with boost packages, and I actually got this fixed for boost 180. This says revision of the port. This is okay, we already made a package for 180 boost, but we know that we got it wrong. So this is updated package, but the same version of boost. So I got this fixed. for the simple case, not for the complex case, because how do you fix this? So you say now when we generate like the boost packages, we say well they depend on the other packages with the version that they are at. So like this should work. Now we reference all boost packages at like 180-1. Well, simple enough, but you can actually still break it, and it's really easy to break again. Like let's imagine that we have this updated project. Now we still depend on boost circular buffer in version 181, which is fixed, and we depend on some library. Some library depends on different part of boost. ICL, this is interval something in version 182. What's going to happen when we install this? Well, 182, 182, 181. Because where these two packages that we are installing, like, where they like cover each other, where they demand the same package, the higher version wins. But for the packages where they don't cover each other, you get the lower version. So you can still break it. It's super easy to break. Be careful. And this isn't just boosting, right? This is for any like split package where you have this big package like boost and split it into small pieces, so you don't have to build everything. Like Qt. Qt is huge. Who here has like built Qt from sources? It takes hours. So like easy package tries to be nice and tells you, okay, so you can install just this part of Qt. And yes, you can do that. And you can get this instead. So yeah, let's talk about another thing that will take a lot of your time, but doesn't cause such issues with correctness. So you can overbuild transitive dependencies. I will explain what I mean. So PC package has this feature, and I think it's like misfeature, but it's a feature. It's called default features of a port. Like port can have features that's part of it to build, and you can say, by default, build it with these like features. I will show you like more about this later. Unsurprisingly, this can give you like large packages you will build a lot, because it's a set of defaults, and usually you don't need them. So, let's say that we have this library that uses OpenCV, and we want to use PNG. I don't know, we want to open some PNG images and do something with them, and in some version, doesn't matter for us right now. So we install it, and we get 44 packages. Because the default features for OpenCV are things like deep neural network support, and like everything. Look at this. We have Cairo here. We have Brooklyn, BZ. I don't know what these are. Like font config, free type. Why do we need free type for OpenCV if we want to manipulate PNG images? No. Good thing is, you can disable the default features. So we update our library manifest. We say, okay, default features false. We don't want them. We just want PNG, nothing more. Let's build this. Now we install 6 packages. 3 of them are BC package helpers for installation. OpenCV, with PNG, this is perfectly reasonable. Like this does not annoy me. 6 packages for OpenCV with PNG. That's fine. Now here is the issue. VC package will ignore you telling it that you don't want default features. It will do it really easily because, like imagine that you now have full SDK. This is some project that will package your library full into an SDK. And that's the only thing it depends on. Your like full still says, hey, I want OpenCV. I still need PNG. I still want no default features. Let's build this. We install 45 packages. The one that was added is the full because you don't set up our dependency. And again, look at this. Cairo, font config, free type, go object. Why do you need this? Well, so the issue is that like VC package completely ignores default features in your dependencies. Like once you are past your project, default features is off, the end, period. This has been an open issue and people have been complaining for over 2 years. A PR to fix it has been open for 2 years and it has been happily ignored for about 2 years. But you know, building really large OpenCV is not the worst thing that can happen to you. At the end of the day, if you just overbuild like your dependencies, you just, okay, your CPU gets warm for a bit, then everything is cached, and you can ignore it forever. It's not much of an issue, but it can get worse. So who here knows FFmpeg library? Awesome library, I love to hate it, but if you default build FFmpeg 4.4, I think, from vcpkg, you would get GPL licensed library. This is unreasonable. You know, like, I have this library, it depends on FFmpeg. I make sure that it's LGPL licensed. You know, so I only use the LGPL classes of FFmpeg. I distribute my library to someone else, they build it, boom, GPL. Not great. I mean, we had like, I don't know, 3 or 4 weeks where we were distributing FFmpeg GPL libraries because, you know, that's how long it took to notice this was an issue. Yeah, actually, I had this conversation yesterday. I noted on like the Discord that I was preparing this talk, and I noted that like, I asked whether like the overbuilding went anywhere because I haven't looked into this for at least a year now, and I noted that like I have like 44 packages from OpenCV. This is unreasonable. No, it's not unreasonable if it's documented. If you don't care about dependencies, vcpkg is free to install whatever it wants. If you want anything else, be explicit. So, you know, my answer is, I mean, I could make it so Catch2 just goes and formats your hard drive and document it. It wouldn't be reasonable, you know? No. You know, so like, I don't think this is going to get fixed in the near future. Surprisingly, I found that this doesn't really affect me in practice much because like for all big ports that we use, we have to have custom ports anyway. We have to write our own. So, you know, I just delete the full regions. Not great, not very good. Okay, this one is kind of, this is not serious, but really easy to run into. You can have like conflict in version resolution constraints, right? vcpkg supports only this kind of constraint. You can say version, I want version that's larger or equal to. You can still fail resolving constraints. How do you do this? Well, let's imagine that we are back with our full SDK, and we want to use upsell in version 2023. This is the newest version, because we have just heard there is like awesome new prefetch library. And we still have libfoo. Libfoo also depends on upsell in version 2021 because it works and like no reason to update, right? So let's build this. Nope, error. Version conflict, blah, blah, blah. Full SDK requires this, which can be compared. Yeah, this just goes off and it keeps going. And this issue is upsell 2021, blah, 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 as scheme string. Upsell 2023 as scheme relaxed. So this is like things that you don't know about until you have to like handle the versioning, like error like this. But, sorry, I will go for it. vcpkg recognizes like 4 different version types. When you declare a package, you can say this package uses version. It's just like some tuple of numbers. Or you can say it's actually like December version, or it's a date version, or it's just a string that doesn't have meaning. Right? And you can't like arbitrarily compare between these. You can't say what's like which version between like this December version and this date version comes sooner. You know, doesn't really make sense to ask like, is 2022-9 it's US format, so 11-29, does this like come before 3.0.0 or not? No, you know, doesn't matter. And so vcpkg only compares versions within the same domain. Strings are incomparable by definition. This is for like versions like this is version red, this is version blue. It's not something you can compare. And actually, like in 2022, I convinced Billy, one of the maintainers, to say that actually like version somewhere and version relaxed should be comparable. So you know when you have like somewhere version and like version non-somewhere, you can say RPs or dirt or not. But you can't write this as a version. Deleting 0 is an issue. I actually talked about this with Billy literally today, and there is a good reason. It's a bad reason, but it's a good reason, because if you say my priority number one is backwards compatibility, there is a good reason why you can't do this. I just don't think backward compatibility is a good priority. And I'll go back for a second. You can actually, you don't have to have 2 ports to have this issue. What if you can have just 1 port and a baseline that's at the wrong version? This is some baseline, this is upsale, this is the new version, and if we build it, we get version conflict, 2 SDK requires 2023, and we compare with baseline version 2021, because one is a string and one is a relaxed version. Yeah, this is not great. The best thing I can say about this is that people don't really write new versions as string versions if they don't have to. So over time, this will disappear as an issue, purely because you won't find old baselines or old packages that rely on string versions. Yeah, one more second for this. So the reason why this was string scheme was that back then you couldn't use this as a version because it wasn't compatible with the expected format of plain old version. Okay, and let's go for the last one. So I have just shown you that baseline does add constraints to your resolution, and how this can just error out your build. And this is actually subtle but surprisingly annoying issue. So because the baseline always adds those constraints. It isn't just if the user didn't have constraint, they will use this. It will always add its own constraints. And so this is a different example. Let's say you have some package that depends on FMT version 190. Once again, you have some baseline. The fact that baselines are commits also can make it really hard to compare them. This is kind of an issue when you use it as well, because sometimes you just see different baselines and you go, okay, which one is newer? I have no idea. So you build it, and you get FMT 10.1.1 because you said, hey, I want 9.1 and newer or equal. So this is correct. It's just not useful. Because if you want your versioning to have priority, if you want the constants that you write to have high priority in baseline, you have to use all baseline. At work, I keep our baseline 5 months back, and that's enough to enable us to do the versioning the way we want. But if you use old version or baseline, you also use old versions of your dependencies that you haven't specified version for explicitly. And because baseline is what gives you the version of the transitive dependencies. So do you transit the node as well? Well, if you don't explicitly say what version you want, you get the one from the old baseline. It's kind of an issue. And the other way you can work around this is to use explicit overrides, because you can just say, okay, no, I don't care about version resolution. This is the version that I get, but these don't propagate from dependencies. For kind of a good reason, but at the same time it makes the abstraction of application management really annoying, because again, example from work. When FMT 10 was released, it had a bug where it wouldn't compile our code. There was some issue in the expert checking of the format string for tuples. It's not great. But we solved it by just saying, okay, we don't need to update to 10.0 yet. And then, our internal consumer, the people who make the SDK, not the library, wanted to update their baseline. So they updated the baseline. Now the baseline said, actually, you get FMT 10.0, and the build broke. So they had to look and, okay, so this library that we don't have in our dependencies broke everything. So what do? Well, that's easy. You just override its version and say, actually, I don't care. My my FMT, which I don't use, will have specific version. Okay, conclusion. So I talked a lot of bad about PC package, and it has a lot of issues. but it's functional. The worst thing that I can say about VC package is that it will forever be kept back by backwards compatibility. Right? If you compare it with Conan, which made major release and broke a bunch of backwards compatibility, VC package won't do this. VC package will always be held back. And some of these issues can cause lots of problems. You can find yourself suddenly distributing GPL back to your customers, which is not great because now you should give them access to all of your source code. But if you are aware of them, they are surprisingly not as annoying as you would think after you get bitten once. And I also want to say that VC gets lots of things right. For example, package methods are not executable. This is a thing I absolutely hate about Conan. If you have Conan package and you want to know what dependency does it have, you have to run Python script. 1, that's slow. 2, that's not really something I want to do with package I don't trust. I don't want to just go and run Python scripts from people all over the internet. And the thing that I actually really like on this package is that it passes almost always the package will use the build system from the upstream. So if you have the documentation on the upstream and it tells you, so use it by this CMake target and you have this extra function, it will be there. And the curated set of packages it provides is really nice. It provides this huge set of packages that are patched and tested together, and they will build on Windows, 64-32 bits, bunch of Linuxes, Mac OS, and so on. They burn an insane amount of money on just having huge Azure fleet, which just keeps building the packages. If you update the package, if you're about to update the package in the VC package upstream in the central repository, it will rebuild the package that you updated, and every single package that depends on this package on Windows, Linux, Mac OS, bunch of configuration, and so on. And it's actually easy to use. When I show you a simple manifest that just gets you started and you get going. But it's not great. It's great if you grade on the curve, and the curve is C++ package management. Yeah, and we have used it for 2.5 years now. It has served us well. It's one of those things that I both hate and actually really like. I hate it because of all the issues I showed you and much more that I didn't. And I really like it because it actually solved a bunch of issues we have had with our builds. So, it's okay. Don't expect much.
Let's see, where is my... So the question is, to which degree these pitfalls with version resolution apply to Conan? Is it any better in this regard?
I actually don't know. Yeah, so the question was about Conan, and I don't use Conan enough to understand its versioning. Because at first glance, VC package versioning is fine, and then you use it for a year, and then you notice that it's not fine. Martin, do you know?
I don't really know because we maintain all the recipes at one place and we build just the one correct versions together. So I don't really know.
Yeah, so Martin has used Conan and they solve it by just updating everything in step. Yes, no.
So Conan suffers from the same issue. Suffered from the same issue in the past, but with the log files now, it's actually much more stable. It doesn't get stuck in the past at all. It moves extremely quickly.
Yeah.
Can you confirm? Okay, so I guess
I think it's you now.
it's out to me now. You actually have an empty slide at the end, which is amazing. Okay, so it is the holiday season, and after all this hating, we need some lighter topic. Now, does anyone even know what is countdown to Christmas, except for like people that saw it last time I talked?
No, but I see anything.
Where is it missing?
Countdown at the end.
On the and it didn't squiggle it when I. Okay, countdown to Christmas is something Hallmark has been doing since 2020, and each year they basically generate around 30 Christmas movies, which are all like not really great production quality, but they are meant to make you feel good. Like every Friday, Saturday, and Sunday, there is a movie, and you're meant to enjoy them. You're not meant to. It's not like deep philosophical. Like no. It's like a very simple. You get your apple tea and some cookies and just enjoy. And I'm loving it so far. So let's take this example. No, actually, this is the timeline, like how a movie usually looks. And when I say usually, I mean like almost always. What I've noticed of all the movies this year I've seen, and it's like almost 20, it's always been a female lead, which only when I prepared this presentation I realized. And so, yeah, there is some issue with the Christmas, either some bad memory, family issues, whatever. It's usually not an actual issue, but not a real world issue, but you need some drama, something like that. And then, like, yeah, something happens, like she goes to the hometown and meets a guy and, you know, all that stuff, everything is getting better. And like 10 to 15 minutes before the end, some twist happens, which is, again, very like basic, very predictable thing. And then in the end, of course, the issue is resolved very easily and everyone is happy and like they find the true love and all that stuff. So let's take an example. This is like a very Scottish Christmas. Now you see these two people, and like when I saw the poster, I assumed that they are going to be together. And I was actually watching this with a friend, so I kind of missed the beginning. And they are actually brother and sister. And I mean, you know how some people just don't know when to stop talking when the movie is on. So I say like, okay, but wait, if he's her brother, then who is she going to fall in love with? This guy shows up. The moment you see him, you're like, yeah, they're going to be together. Pretty obvious. I mean, he's one of the three female characters. It's like, yeah, it's not gonna be a servant, definitely. Then, like, they have this conversation. Actually, their mother, this guy is married, and they don't have kids. And like, the mother at one point mentions like hoping to get grandchildren. And then they talk how the relationship is a bit rocky, and like, yeah, they've been trying to get a kid, no success. And you know, the movie is going to end with a scene where it's the next year's Christmas and they have a baby, and of course the movie ends exactly that. So, and like, so the guy, yeah, so they are together. Obviously, the mother is there, she's happy, they're still married, they have a child. It's like, it's exactly what you would expect. Now, the question you are all wondering is like, what does this have to do with C++? Let me tell you. Code reviews. Now, if it's not obvious, I would like to review code the way I watch a Hallmark Christmas movie. In a sense, it should be predictable. Like, it should not, there should not be plot twists and like, I need to contact 3 people and then I read some lines and then I go back and then has anyone seen the movie Memento? With the guy that has like 15 seconds of memory and then you go back to actually figure out what happened and then, yeah, who is lying, who's not. No, I don't want that. I don't want the drama. I want simple, like, yeah, it's obvious. Like the moment I see the variable, I'm like, okay, this is going to be used for that. And it's like going to be that way. Yeah, of course, it's like not going to happen, but try. Like, when you are about to send your code to review, ask yourself, is this like simple enough to be a Hallmark Christmas movie script? And if it isn't, why isn't it? Like, what can you do to make it simpler, more predictable? And if you've been to meeting C++ this year, or when it goes online, Ivan, Dr. Ivan, gave a closing keynote, and he came up or like stole from somewhere this term, idiom-driven development, where he's like, yeah, we should just like use idioms and stuff like that. And of course, I'm not gonna talk like about design patterns and like, I think like clean code and all that stuff has been basically beaten to that at this point. No point in repeating it. But this idea of idiom-driven development I actually like, because you can have idioms that are specific to your domain and your code base that basically just make your code predictable to anyone who is actually familiar with your code base. Like, you don't need a cult of design patterns and all that stuff. Like, you just, there needs to be some sort of structure. And when you read a review, it's not like when someone reads a review or when you will read someone's review, it should just be like predictable from the beginning to the end. From the description of the commit, you should be able to just predict how the code is going to go. And then, of course, there are details that are different, like from movie to movie or the review from review. But the fact that you use a different naming scheme or different indentation or stuff like that should not really like throw me off. If you are using the pattern, the idiom that I know, I should be able to like predict what happens. And the actual most important part comes from a different movie, which is Everything Christmas. And like, I mean, yeah, they fall in love in the end and all that stuff. And this, I mean, it's a very cliche line, but I really liked it. Like, a word of advice: don't pick. Once in a while, just let the world be a magical place. Not the code you use, but the world. Yeah, like basically this guy is something like a magician, but not like, is he a real Santa? Is he not? Like, the answer is, if you believe, then yes, he is. If you don't, then he's not. And like, yeah, sometimes just like watch a Hallmark Christmas movie, enjoy yourself, don't critique everything. And if I have managed to warm your dead cold hearts just a bit, I mean, is the holidays, the season of giving. I found this, I don't know, give a good deed for Christmas thing, which has a bunch of like charities if you want to donate or do something like that. Or you just like go out to Christmas market and you will find some charity definitely there. For the end, I just need to give credits to this site where I got the slides from, because like, yeah, obviously did not create something this pretty. And that's it for me, and that is all from this year's lightning talks. And, okay. I mean, I assume there are no questions. That's the